Hello everyone, welcome to Concepts in Chemistry YouTube channel. So today in this video we will discuss some memory based questions and their maximum possible answers from BARC 2022 second slot exam. So फर्स्ट एग्जाम कंडक्ट हुआ था 2 अप्रैल को एंड सेकेंड स्लॉट एग्जाम कंडक्ट किया गया था 6 अप्रैल को. So we already discussed more than 50 questions from first slot exam जो 2 अप्रैल को conduct किया गया था. In this video we will discuss some questions जो मैंने कुछ questions मैनेज कर पाया जो सेकेंड फेस एग्जाम होल्डर थे उन लोगों के पास से कुछ क्वेश्चंस मैंने मैनेज कर पाया. सो दिस इज part 1 video of memory based questions from second slot exam. So let's see some questions from second slot exam. So this is questions 1. So in this dihydroxyaldehyde the reagent was like that, phosphonium halide with sodium ethoxide. So see in this reactants on carbonyl means aldehyde group is there. So there is this is phosphonium halide, but see so in presence of base first and this hydrogen from this carbon adjacent to phosphonium carbon, this hydrogen are acidic. So first sodium ethoxide means OET minus abstract hydrogen from this place, and now this is become phosphonium halide. So now this halide react with carbonyl compound via Wittig reactions, normal Wittig reactions to form a alkene. So in this case cis alkene will form because if the halide is is a stable halide, means a very strong electron withdrawing group attached to this carbanion carbon, then we will get trans alkene or E alkene from that phosphonium halide. So in this case we will get cis alkene. So after getting cis alkene, so see in this compound, this is the product of Wittig reactions. See there is a allylic bromide. So this is a allylic bromide, and this bromide, this CH2 carbon is prone towards SN2 nucleophilic substitutions. So in the reaction medium, since sodium ethoxide is present, so this OAT minus substitute means substitution will happen in this carbon to form this kind of molecule. So मैक्सिमम क्वेश्चन का ऑप्शन उन लोगों ने याद नहीं कर पाया. जस्ट मेरा कुछ फ्रेंड सेकेंड स्लॉट एग्जाम में उन लोगों ने सेकेंड स्लॉट एग्जाम में कुछ फ्रेंड मेरा सेकेंड स्लॉट एग्जाम दिए थे. सो उन लोगों के पास से कुछ क्वेश्चन मैंने मैनेज कर पाया, बट मैक्सिमम केस में ऑप्शंस उन लोगों को याद नहीं है. सो इस टाइप का क्वेश्चन था. शायद एग्जैक्ट क्वेश्चन मैच नहीं हो सकता है. सो प्लीज आप लोग कमेंट करके बताना एग्जैक्ट क्वेश्चंस और कहाँ रिएजेंट और कुछ स्ट्रक्चर में कुछ डिफरेंस भी हो सकता है. प्लीज आप लोग वो कमेंट करके कमेंट बॉक्स में बताना. जस्ट मैंने कुछ 90% ट्राई किया एग्जैक्ट स्ट्रक्चर, बट उन लोगों को ऑप्शन नहीं याद था, इसलिए मैंने ऑप्शन नहीं दे पाया. सो this is the first question from organic chemistry. So this will be the possible product, maximum possible product. You can think also that first this bromine is there and beta hydrogen is there. So in presence of base beta elimination first हो सकता है beta eliminations, क्योंकि bromide is a good living group and base is present and also beta hydrogen is present. So see if beta elimination will occur, yeah, there is chance for beta elimination, but if there is beta elimination अगर ये बीटा एलिमिनेशन हो जाता है सो फॉस्फोनियम इलाइट, देन फॉस्फोनियम इलाइट फॉर्म नहीं होगा। सो इन रिएक्शंस में कार्बोनिल कंपाउंड है एक एल्डिहाइड, वेरी रिएक्टिव कार्बोनिल कंपाउंड, एंड इसमें चांस है एक फॉस्फोनियम इलाइट फॉर्म होने का, सो दैट इट कैन रिएक्ट विद दैट एल्डिहाइड ग्रुप। दैट्स व्हाई इन दिस केस फर्स्ट बीटा एलिमिनेशन नहीं होगा, फर्स्ट होगा इलाइट फॉर्मेशन, देन आफ्टर एल्किन फॉर्मेशन at last there is possibility of substitution reactions by SN2 mechanism. So after at last substitution reaction होगा SN2 mechanism के थ्रू, जो फाइनल प्रोडक्ट ए होगा। जिन लोगों ने सेकेंड स्लॉट एग्जाम में पार्टिसिपेट किए थे, मीन्स जिन लोगों ने सेकेंड स्लॉट एग्जाम में सेकेंड स्लॉट एग्जाम में जिन लोगों ने सेकेंड स्लॉट एग्जाम में एग्जाम दिए उन लोगों को पता चलेगा ये वाला ऑप्शन उधर था या नहीं, बट अकॉर्डिंग टू मी this is the maximum possible product, because this will be not the product, because someone might be think that this will be the product, but after formation of this product, see there is a allylic bromide. Allylic bromide is a very prone towards SN2 substitutions. So since there is a NaOH base, so substitution हो सकता है, there is maximum possibility for SN2 substitution. So this will be the maximum possible product for these reactions. So now question 2. So this is the simple and very easy questions from Beckmann rearrangement. So first this hydroxylamine react with this carbonyl compound to form this so hydroxylamine after forming this imine, this is a, so what is this compound called as? So N-hydroxylamine. So this is imine and this is N-hydroxylamine, or so this compound formed after react with NH2OH in presence of catalytic amount of acid. Now in presence of acid, this OH2 become protonated, and as soon as this OH2 leaves from this NO bond breaks, this bond, anti of this bond migrate to these positions. If we draw OH2 in this side, then this bond will break. You all know that anti bond migration of anti box is more favored. So we draw in this case OH2 in that side, so this bond, we showed this bond will break. If we draw OH2 in that side, then obviously this bond will break. So this, since it is a symmetric cyclic molecule, so there is no, so both the options are correct, this bond or this bond, there is no differences in both migrations. Then in this way we will get this product, a cyclic amide. So this is a very simplest and easiest reactions from Beckmann rearrangement. So this is cyclic amide. So it is called lactam molecule. We call cyclic amide as lactam, as we call cyclic ester as lactone. As same likewise we call cyclic amide as lactam. So let's move to the next questions. So this is also from organic chemistry. So on tertiary butanol, on tertiary alcohol, means this is a tertiary alcohol react with acetonitrile in presence of acids. So what is the product? So this is name reactions. These reactions from a name reaction, that is Ritter reactions. So this is particularly for synthesis of trialkyl amine. These reactions is particularly for synthesis of trialkyl amine, means tertiary amine. So first, in presence of H plus, this OH group protonate, and after leaving of this OH2 group as water, there is forming a tertiary carbocation. Now this lone pair of nitrogen in acetonitrile will attack this carbocation, and now this bond will break, and now water will attack this carbon to form a amide. So this is called Rita reactions. Now if we hydrolyze this amide, we will get amine. This bond will hydrolyze amine, so we will get tertiary amine. So sorry, not tertiary amine. So sorry, not for tertiary amine. So this is for a primary amine attached with a tertiary alkyl group. Normally this type of amine we can form by these reactions. A primary amine attached with a tertiary alkyl group. So if we hydrolyze these reactions, but in the exam I think so hydrolysis is not there, just H plus was given, so we will get the amide. So I think there are four options, and also the IR value was mentioned in the exam. So IR value was 1643 centimeter inverse. That is for we all know that is for amide carbonyl frequency. So in amide carbonyl frequency around 1650 to 1660 centimeter, and IR 3286 centimeter was given. We all know that NA's frequency, so NA's stretching frequency is around 3100 to 3500 centimeter inverse. So these values were given. So, and I think four options from different structural amide were given. So from this from those structures, so the correct amide structure will be this. So the tertiary alkyl group attached with the nitrogen, not with the carbonyl group. So this is the correct answer of these reactions. This is the name reactions, Ritter reactions. So next questions was a simple questions. So this questions was given, the name of the question was given, the name of the compound, the name of the compound was given. So we have to find the most stable conformer. So we all know from the anomeric effect, so the axial conformer means that OMe in the axial positions, in this case it's become more stable. So due to anomeric effect, so some electron from the lone pair of oxygen, some electron is transferred to the CO sigma star, so sigma star of the CO bond, and for this case this CO bond become stronger, and this CO bond becomes somewhat weak. So we all know from anomeric effect, if the electron withdrawing group present in this case and oxygen is in the ring, then the axial substituent is more stable because of the anomeric effect. So next question देख लेते हैं. ये क्वेश्चन था, ये बहुत एक अच्छा क्वेश्चन था, इंटरेस्टिंग क्वेश्चन. So this is a alpha beta unsaturated ester. Alpha beta unsaturated ester was given, and 2 equivalent of phenyl magnesium bromide main Grignard reagents followed by acidic workup. So we all know how normal ester react with Grignard reagent. So it will react 2 equivalent of Grignard reagent to form a alcohol, secondary alcohol. So in this way, first equivalent attack this carbonyl carbon, not since it is a Grignard reagent, so it will not attack the double bond, means beta position of the alpha beta unsaturated carbonyl compound. It will attack directly the ester carbonyl molecule. Now this negative charge goes back to open this O group. So now this O group, after accepting H plus, become OH. So again it's become alpha beta unsaturated carbonyl. First it was alpha beta unsaturated ester. Now after reacting with first equivalent of Grignard reagent, it become alpha beta unsaturated ester. Again it will react second equivalent of Grignard reagents to form secondary alcohol after acidification. Now in the reaction medium acid is present, so this OH group become protonated and leave as and this OH2 plus, this OH bond break, water leave as a living group. So water leaves as a living group to form a stable, very stable carbocation. 2 phenyl ring is there. This is benzylic positions. So sorry, on double bond should be there. I missed the double bond. On double bond should be there. So after leaving this OH group as a water molecule, so it will form a stable carbocation. Now this OH, this lone pair of OH group attack this carbocation to form this kind of molecule. So this is the correct answer of these questions. So after reaction of two equivalent of Grignard reagents with alpha beta unsaturated carbonyl, first second degree alcohol formed, then in presence of H plus this OH group protonated, leave as water molecule, and left a stable formation of stable carbocation. So leaving of this OH group is so leaving of this OH group leading to the formation of the very stable carbocation. See, 2 pH ring on double bond is there. So this carbocation is very stable, and now this OH group attack this carbocation to form this kind of molecule. So this is the correct product of these reactions. So I think among the 4 options, one option should be there. So let's see the next questions. So again from chemical kinetics. So in first slot exam means जो एग्जाम 2 अप्रैल में कंडक्ट किया गया था, उस एग्जाम में सेम टाइप क्वेश्चन पूछा गया था. उस एग्जाम में क्वेश्चन पूछा गया था ln r reactant concentrations, ln r versus time. if we plot ln r versus time, we will get a straight line with negative slope. Then what will be the product, what will be the order of the reactions? So ये 2 अप्रैल में जो एग्जाम कंडक्ट किया गया था उसमें पूछा गया था. नाउ सेकेंड स्लॉट जो 6 अप्रैल में हुआ उस एग्जाम में सेम क्वेश्चन जस्ट थोड़ा चेंज कर दिया गया. इन लोगों ने पूछा, ऑर्डर भी मेंशन किया गया फॉर सेकेंड ऑर्डर रिएक्शंस, फॉर अ सेकेंड ऑर्डर रिएक्शंस which plots gives a straight line. I think they are not mentioned any negative slope or positive slope as much as I can remember from my friends. So ये positive और negative slope mention नहीं था. So for second order reactions, which plot can give a straight line? So 1 by C versus T, C versus T, ln C versus T, ऐसा कुछ ऑप्शन था. So हम लोगों ने एक अलग वीडियो में ये तीनों डिस्कस किया. मैंने जो फर्स्ट स्लॉट एग्जाम का जो क्वेश्चन डिस्कस किया हम लोगों ने उसमें भी मेंशन किया. सो कैसे हम लोग इजीली विद इन 30 सेकेंड्स ऐसा क्वेश्चंस सॉल्व कर लेते हैं, ग्राफ रिलेटेड क्वेश्चंस टू फाइंड द ऑर्डर ऑफ द रिएक्शंस, हम लोगों ने डिस्कस कर लिया केमिस्ट्री कॉन्सेप्ट बूस्टर सीरीज में. सो if we saw this video, we can find that 1 by C versus T gives a positive slope straight line for second order reactions. For zero order reactions, the plot C concentration versus time give a negative slope straight line. For first order reactions, the plot is ln C versus T, and that will give a negative slope straight line. So ये क्वेश्चन में था सेकेंड ऑर्डर रिएक्शन कौन सा प्लॉट एक स्ट्रेट लाइन, सो कौन सा प्लॉट में स्ट्रेट लाइन हम लोगों को मिलता है. सो फॉर सेकेंड ऑर्डर रिएक्शन 1/c वर्सेस t जो प्लॉट होगा उसमें से उसी प्लॉट में हम लोगों को एक पॉजिटिव स्लोप स्ट्रेट लाइन मिलता है 1/c वर्सेस t प्लॉट में फॉर सेकेंड ऑर्डर रिएक्शन. सो फॉर दिस क्वेश्चंस आंसर विल बी 1/c वर्सेस t. बट प्रीवियस जस्ट फर्स्ट फेज और फर्स्ट ऑर्डर एग्जाम में पूछा गया था ELN-C वर्सेस टाइम, एक प्लॉट में एक स्ट्रेट लाइन मिला विथ नेगेटिव स्लोप, व्हाट इज द ऑर्डर ऑफ द रिएक्शंस. सो इन दैट केस द आंसर वाज फर्स्ट. फॉर फर्स्ट ऑर्डर रिएक्शंस ELN-C वर्सेस टाइम प्लॉट में हम लोगों को स्ट्रेट लाइन मिलता है विथ नेगेटिव स्लोप. So next question from electrochemistry. So they cannot properly remember the actual questions, but उन लोगों के सिर्फ पता था लिक्विड जंक्शन पोटेंशियल रिलेटेड क्वेश्चन था और which electrolyte will be more effective for to eliminate liquid junction potential. So we know already. So we use some electrolyte to eliminate the liquid junction potential. So in that case we use normally potassium chloride or ammonium nitrate. So normally we use potassium chloride or ammonium nitrate because this in this electrolyte the mobilities of cation and anion are somewhat identical. So that's why we use this kind of electrolyte in place of instead of to eliminate the liquid junction potential. So we use electrolyte whose cation and anionic mobilities are identical. So that kind of electrolyte like potassium chloride KCl, ammonium nitrate, ammonium nitrate, sorry, not ammonium nitrate, ammonium nitrate, NH4 NO3. So NH4 to NO3. So ammonium nitrate we use for this kind for elimination of liquid junction potential. So एक M क्लोरीन एक इलेक्ट्रोलाइट आई थिंक दिया हुआ था क्वेश्चन में, हम लोगों को M निकालना था which is perfect for this electrolyte. M is हाइड्रोजन, सोडियम, लिथियम और पोटेशियम. आई थिंक ये कुछ ऑप्शन था. So if that was the questions, then obviously potassium will be the correct answer. Means KCl or some case ammonium nitrate we use to eliminate liquid junction potential. So for these questions potassium will be the correct answer. Potassium is the correct answer if that was the questions regarding inert electrolyte we use in solved this to remove the liquid junction potential. Then the main criteria is this type of electrolyte has positive cation and anion has cation as well as anion have identical mobilities. That's why we use this kind of inert electrolyte in solved this to remove liquid junction potential. So next question देख लेते हैं. So this questions from so organometallics. So we all know that so the chromium CO(6) complex was given, and if we treat it with PPH3 means there will be just ligand exchange. PPH3 attack one CO group. So PPH3 substitutes on CO group. So PPH3 attack. Then the questions was like that. Then the product, what will be the bond length, CRC bond length and bond length in CO. So as much as I can remember, so they told me the question was the bond length, not the bond stretching frequency. So bond length, so if we want to find bond length means, so bond stretching is the opposite phenomena of bond length. If a bond length is more bond length means the length of bond is more, mean we can say that that bond is weak. If the bond length is short, then we can say that the bond is more stronger. So if this was the questions, then we all know that the carbonyl, the more pi accepting ligand is NO plus, and second most pi accepting ligand is CO group. So in this compound all are CO, and CO group is the second most pi accepting ligand. So after treating with triphenyl phosphine, one CO group just exchange. Now in the questions I think नॉर्मली ऐसे पूछा गया था, क्रोमियम सी बॉन्ड लेंथ एंड सी ओ बॉन्ड लेंथ इन कार्बोनिल, उसका क्या चेंज होगा, वो बॉन्ड लेंथ में क्या चेंज होगा. बट ये ट्राइफेनाइल फॉस्फीन ये कॉम्प्लेक्स में अटैच होने के बाद मैक्सिमम 99-95% इफेक्ट जस्ट ट्रांस सीओ के ऊपर देखने को मिलता है. अदर्स जो कार्बोनिल ग्रुप अटैच है ये क्रोमियम के साथ, उसमें से ये इफेक्ट उतना नहीं देखने को मिलता है. We will find the effect of this ligand, this substituted ligand, whether it is more pi accepting or less pi accepting, means electron donating, just the trans of that CO. Since this PPH3 attached in this place, so maximum effect will be observed in that CO only, that CO and that CC bond only, not this. 95, more than 95% effect will be observed in that CO and that CC bond, just the trans of that newly coming ligand. So you all know that PPH3 is less pi accepting than CO. So if CO is there, there will be equally pi acceptance by the ligand. Now one CO is exchanged by PPH3. PPH3 is less pi accepting than CO. Now in this case, if we compare, if CO is there, there is no change in pi acceptance in all the side. Now PPH3 exchanged CO, so PPH3 has less pi accepting power than CO, means it has more pi donating power. Now it will donate some electron to the metal center. Now this metal center is somewhat donate more electron to the trans CO. If carbonyl group is there in this place, there is no questions about the pi acceptance and donations. The pi accepting the pi donation of the metal to ligand and ligand to metal are same in all the case, all the 6 ligand. But since one PPH3 is there, so this PPH3 will donate some electron to the metal, and this metal, that's why this metal will donate some electron density to the pi star of this CO bond, not the other CO bond. 99% केस में जो इलेक्ट्रॉन PPH3 डोनेट करता है somewhat, because PPH3 is less pi accepting than CO, it is more pi donating, it will donate some electron to the chromium metal. Now chromium metal electron density becomes somewhat increased, and that's why it will donate the electron density to the pi star of CO of this CO, thus turn to the PPH3 ligand. Now since chromium donating some electron to the CO, now this CRC, chromium metal carbon bond, become somewhat strong, means this bond becomes somewhat shorter. And since this chromium metal gives electron but donates electron density to the pi star of CO, the CO bond length become increase, or CO bond become weak, or frequency of CO bond become less. So there are three phenomena, but in the questions I think they asked about only bond length. So by exchanging on CO group by triphenyl phosphine, the trans CO carbonyl, this metal donates some electron density to the pi star of CO. Now this chromium C bond becomes shorter. Bond becomes shorter means bond length become shorter, and this chromium C bond becomes strong, and the frequency, means nu bar value of this chromium C bond become higher than this case. If you compare this case and this reactant product, in product the chromium C, metal C bond become shorter, that this metal C bond become stronger, the nu bar value means so frequency value, nu bar value will be more for this chromium C bond as compared to the reactant. Now compared to the ligand, if we compare this CO ligand, because we showed in the mechanism here the PPH3 donates some electron to the metal donates some electron to the pi star of the CO. Now the CO bond become somewhat longer, CO bond become weak, so the nu bar value of the CO bond become less as compared to this reactant. So the in the questions they asked about the bond length. So the product, the chromium C bond length, metal C bond length become shorter, so the bond becomes shorter as compared to the reactant, and the CO bond length, the carbonyl bond length become longer as compared to the reactant. So this bond become weak, or you can say longer, or chromium C bond become stronger, or you can say the bond become shorter in the product. So we all know this kind of phenomena. If we change this CO by NO plus, then NO plus we know the most pi accepting ligand, then NO plus will accept more electron than carbonyl group, because carbonyl group in the reactant NO plus, then NO plus more electron accept if we use NO plus, then NO plus more electron accept then NO plus ज़्यादा इलेक्ट्रॉन एक्सेप्ट करता है ये क्रोमियम मेटल से, then NO plus, since NO plus accepting more electron from this chromium metal, that's why the donating power of the chromium metal, donating power of electron to the of the chromium metal to the trans CO group will be less. That's why this chromium metal cannot donate electron density to the trans CO as compared to the reactant if we used NO plus in place of PPH3. So in that case, this chromium C bond become weaker or longer, and since the electron donating power of this chromium metal become low, chromium metal to the pi star orbital of CO become low. That's why the CO bond become stronger, carbonyl bond CO bond become shorter, and the staging frequency become more if we use NO plus in place of PPH3. So just opposite phenomena will happen in that case. So now let's move to the next questions. So this is the simplest questions from quantum, that is on the box. So just the energy differences between first excited state and second excited state energy state for a particle in on the box problem. So you all know the energy expressions for on the box: n square h square by 8ml square. L square is the length of the box on the box. N is equal to quantum number. So for n is equal to 1, this is for ground state. For n is equal to 2, this is first excited state. For n is equal to 3, this is second excited state. N is equal to 1 for on the box, 0 means ground state. You can say n is equal to 1 is for ground state, n is equal to 2 first excited state, n is equal to 3 second excited state. So they asked about the energy difference between the first excited state and second excited state. So second excited state means the n value is 3, first excited state means n value is 2, and n is equal to 1 means ground state. So if we calculate this value, we will get 5h square upon 8ml square. So this is the energy differences of second excited state and first excited state for on the box problem. So now on questions from thermodynamics, ऐसा कुछ क्वेश्चन था जो वॉल्यूम भी को हम लोग को कैसे एक्सप्रेस कर सकते हैं. सो कुछ ऐसा टर्म था. सो उन लोगों को ऑप्शन याद नहीं है, बट सेम क्वेश्चन पूछा गया था फर्स्ट स्लॉट एग्जाम में, जो हम लोगों ने ऑलरेडी डिस्कस किया, हम लोगों ने डिस्कस किया वो वाला, उसमें फर्स्ट सॉल्ड एग्जाम में पूछा गया था एंट्रोपी को, एंट्रोपी को कौन से एक्सप्रेशन में हम लोग एक्सप्रेस कर सकते हैं। सो इसमें दिस 4 thermodynamic equations we already obtained from this this triangular box. So we establish all the thermodynamic equations only for this triangular box, or you can say square box, both are same. सो क्वेश्चन ये था वॉल्यूम को हम कौन सा एक्सप्रेशन में एक्सप्रेस कर सकते हैं। सो फ्रॉम दिस 4 एक्सप्रेशंस, फ्रॉम एक्सप्रेशन फ्रॉम इक्वेशन 2, if we divide equation 2 by dp maintaining constant entropy, then we will get del A is del P at constant entropy equal to V. At constant entropy means this ds becomes 0, then del A is del P at constant S equal to V. From equation 4, if we divide these equations with del P, del G, del P at constant temperature, we will get V. So I think चार ऑप्शन में कोई इन दोनों में से कोई एक ऑप्शन था, और ऐसा भी हो सकता है जो 1, 2 में ये दोनों ऑप्शन था, और आंसर में पूछा गया था जे 1 and 2, क्योंकि सेकंड फर्स्ट स्लॉट में दोनों ही एंट्रोपी का दोनों एक्सप्रेशन दिया हुआ था, और फाइनल ऑप्शन में था 1 and 2, 1 only, 2 only या 3 only. तो आंसर उस केस में आंसर था 1 and 2, बिकॉज 2 करेक्ट एक्सप्रेशन फॉर एंट्रोपी उसमें दिया हुआ था। बट इस वाला क्वेश्चन में पता नहीं दोनों सही एक्सप्रेशंस और एक सही एक गलत, एक सही 3 गलत दिया हुआ था, ये पता नहीं, बट क्वेश्चन सेम था, वॉल्यूम को हम कौन सा एक्सप्रेशन में एक्सप्रेस कर सकते और इन टर्म ऑफ थर्मोडायनामिक स्टेट। सो वॉल्यूम को हम सिर्फ ये दोनों टर्म में एक्सप्रेस कर सकते हैं। सो आइदर डेल ए इज डेल पी एस और डेल जी डेल पी टी। सो ये क्वेश्चन था एक, और एक क्वेश्चन था सो इनऑर्गेनिक कोऑर्डिनेशन केमिस्ट्री रिलेटेड। सो this is we have to find the 16 electrode complex. So 4 complex are given, that is so 4 complex are given, we have to find the 16 electron complex. So if we calculate the electron count of this 4 complex, then we will find only this rhodium chloride triphenyl phosphine will be the 16 electron complex, other 3 are 18 electron complex. So so we see this kind of complex in Wilkinson catalysis. So in Wilkinson catalysis, this rhodium Cl-PPH3 is the main form of the active catalyst. We will see this kind of complex in Wilkinson catalysis. So in these questions, the correct answer is this one, which is 16 electron species or 16 electron complex. Now another question था, so 3-4 I think 3 या 4 बोरोन क्लस्टर मीन्स बोरोन हाइड्राइड दिया हुआ था, उसमें से हम लोगों को निकलना था which on is nido cluster, 3-4 बोरोन हाइड्राइड कुछ दिया हुआ था बोरोन क्लस्टर, we have to find which one is nido. सेम क्वेश्चंस एक फर्स्ट स्लॉट में पूछा गया था, उसमें B5H9 B5H8 माइनस B5H8 माइनस वो क्वेश्चन था, ये कौन सा क्लस्टर में बिलोंग करता है, निडो, क्लोजो और एराक्नो। सो वो भी निडो ही था। B5H8 माइनस मीन B5H5, if we remove 3 hydrogen from H8, then it's become B5H5, 1 minus was there, and since we remove 3 hydrogen, we have to put 3 negative charge, so B5H5 4 minus means nido. सेम क्वेश्चन पूछा गया सेकेंड स्लॉट में, 3-4 बोरोन हाइड्राइड का क्लस्टर दिया हुआ था, उन लोगों में से हम लोगों को निकलना था which one is nido. So this B5H9 will be nido cluster. So B5H9 means B5H5. Since we are not writing here 4 hydrogen, we only write here B5H5. So we are removing 4 hydrogen from this complex. That's why we have to put 4 negative charge in that complex. So B5H5 4 minus means nido. So 13 क्वेश्चन में मेंशन किया स्टेट सॉलिड केमिस्ट्री का कुछ क्वेश्चंस, तो सेम क्वेश्चंस था, इसमें 2 क्वेश्चन था, उन लोगों को पता नहीं है क्वेश्चन किया था, बस कुछ याद है उन लोगों को बीसीसी लैटिस रिलेटेड कुछ क्वेश्चन था। एक क्वेश्चन था ऐसा, सो फॉर बीसीसी लैटिस रिफ्लेक्शन ऑब्जर्व्ड व्हेन द H प्लस K प्लस L वैल्यू, सो ऐसा कुछ मिलर इंडिसेस दिया हुआ था 3-4। सो फॉर बीसीसी लैटिस व्हिच प्लेन विल गिव द रिफ्लेक्शन, ऐसा एक क्वेश्चन पूछा गया था। सो वी ऑल नो फॉर ऑब्जर्व्ड रिफ्लेक्शंस फ्रॉम बीसीसी लैटिस द Miller indices, the summation of Miller indices means H plus K plus L should be even. So to observe the reflections for BCC lattice, the H plus K plus L value should be even. So I think there are 4 options. तो उसमें से C 4 ऑप्शन में से ऐसा कुछ ऑप्शन था जिसमें से H plus K plus L value even होना था। So 0 we consider 0 as even also. So 0 is belong to even. So 1 plus 0 means 2. So this plane also we will also observe reflection from this plane, because this is the summation of Miller indices of this plane is even. So second plane is, so we cannot observe reflection from second plane. Third plane also we observe, because 2 plus 0 plus 0 equal to 2, that is also even. So 2 plus 1 4, that is also even. So these are not the options I wrote. So I wrote 4 plane here just to see, just to show you. So from what kind of plane we observed the reflection for BCC lattice. So for BCC lattice, to observe reflections, the summation of Miller indices means H plus K plus L value should be even. So just for extra informations, for FCC lattice, if we have to observe the reflections for FCC lattice, so the condition is either H, K, L or all should be odd or all should be even. Here is no summation conditions. In this case, individually H, K, L all should be in odd or all should be in even form. Then we will get the reflection from plane for FCC lattice. Since 1 1 1 plane all are odd, we will get reflections, right? 2 0 0, so all are even, 2 even 0 even 0 even. From this plane we also observe reflections. 1 0 0, we will not observe reflection from this plane for FCC lattice, because 1 is odd, 2 0 0 is even. So either all should be odd or all should be even. 2 2 0 we will observe, because all are even. 2 2 1 we will not observe, 2 2 is even, 1 is odd. So these are the conditions for FCC and BCC lattice to observe reflections. And for simple cubic lattice, from all combinations either even or odd, no problem, we will get reflection from all type of plane. So on questions from so this is the 14th questions. So शायद क्वेश्चन ये था 1 ml 0.1 on normal HCl, if we add 0.1 normal HCl, 1 ml 0.1 normal HCl in 1 liter of sodium chloride, 1 liter of sodium chloride solutions. So क्वेश्चन ये था, मैंने क्वेश्चन शायद क्वेश्चन मेंशन करना भूल गया. So क्वेश्चन ये था, if we add 1 ml 0.1 normal HCl to a 1 liter solution of sodium chloride, then what will be the pH of the resulting solutions? If we add 1 ml 0.1 normal HCl to a 1 liter solutions of sodium chloride, then what will be the pH of the resulting solutions? So ये रिएक्शन को हम लोग दो तरीका में सॉल्व कर सकते हैं. So first way is that we know that sodium chloride is a strong electrolyte, or you can say salt. So it's neutral. Salt, the solution of salt is neutral, you all know. So it will not affect the pH of the solutions. So since this salt is neutral, so it will not affect the pH of the solutions, resulting solutions. So we can find the concentration of the resulting solutions, the concentration of H plus. So from this N1, V1 into V2. So first N1 means 0.1 normal HCl, we are adding 1 ml, 0.1 normal HCl 1 ml, and the final solutions concentration, we have to find the concentration of H plus in final solutions. It will, so final solutions, in the final solutions the volume become 1 liter plus 1 ml means 1.001 liter, means 1.001 ml. So we are adding 0.1 normal 1 ml in a solutions of 1 liter of NaCl. NaCl is a neutral salt, so it will not affect the pH of the solution, whole solutions. Now we have to find the concentration of HCl or H plus. Concentration of H plus जो होगा, concentration of HCl same ही होगा, because it is a strong acid. So we have to find the resulting we have to find the concentration of resulting solutions. Now 0.1 normal 1 ml HCl we are adding to the 1 liter of sodium chloride. Now the resulting solution, this is initial condition. The resulting conditions, we have to find the concentration of resultant solutions and the volume of resultant solution. What will be the volume of resultant solutions? It will be 1001 ml, because previously ओरिजिनली 1 लीटर सोडियम क्लोराइड था, हम लोगों ने ऐड करा 1 ml HCl. So total volume now become 1001 ml. So if we calculate, so we will find the N2 means the concentration of the resultant solution become close to 10 to the minus 4. So 9.99 10 to the minus 5 means we can say 10 into 10 to the minus 5, so 10 to the minus 4. Now the concentration of H plus become 10 to the minus 4, so pH become minus log 10 of H plus, so close to 4, around 4. So ये क्वेश्चन हम लोगों ने और एक तरीका से सॉल्व कर सकते हैं. सो देखते हैं नेक्स्ट प्रोसीजर कौन सा है. जस्ट वी हैव टू फाइंड द मोल नंबर, how much mole we are adding to the solutions. So 1 ml 0.1 normal HCl we are adding. So we have to find 1 ml 0.1 normal HCl equal to how mole HCl, how much the mole of HCl we are adding to the solutions. So we all know 1000 ml 1 normal HCl means 1 mole. 1000 ml 1 normal HCl, we can say it is 1 mole. So 1 ml 0.1 normal HCl, it become 10 to the power minus 4 mole. So we are adding 10 to the power minus 4 mole to the 1 liter solutions of 1 liter solutions of NaCl. Total volume of the final solution become 1 ml into 1000 ml, means we are adding 1 ml solution, 1 ml of these solutions. 1 ml we are adding, we have to consider the volume. 1 ml this much HCl 0.1 normal HCl means 10 to the minus 4 mole. So total volume of the solutions, total volume, or we can say final volume of the solutions after adding the HCl become 1.001 liter, and the mole number of HCl is 10 to the minus 4 mole. So we all know the concentration, we can write mole per liter. So in that solutions, concentration of H plus is concentration of H plus, how can we write? Mole number of H plus divided by total solution. So mole number of H plus, we found that 10 to the minus 4. We calculate the mole number of H plus 10 to the minus 4, and the volume of total solutions become 1.001 liter. So this value will also become close to 10 to the minus 4. So pH should be 4. So for this questions the answer is 4. So pH हम लोगों को pH निकालना था, so answer is 4. So next question देख लेते हैं. So एक क्वेश्चन इंटेंसिव प्रॉपर्टी रिलेटेड एक क्वेश्चन पूछा गया था शायद. इंटेंसिव प्रॉपर्टी मीन्स दैट mass dependent and mass independent properties. So कुछ प्रॉपर्टीज दिया गया था, मोलर कंडक्टेंस, वॉल्यूम और कुछ था जिसमें से हम लोगों को इंटेंसिव प्रॉपर्टीज निकालना था. सो इंटेंसिव प्रॉपर्टीज मींस मास इंडिपेंडेंट and extensive properties means mass dependent. So mass dependent, so you all know that that mass is so volume, mass, energy, number of moles, free energy, enthalpy, entropy, heat capacity, length, these are mass dependent or extensive properties. And intensive properties are that molar conductance, mole number, so refractive index, molar entropy. If the term is molar, then it will be intensive. Molar enthalpy, so rate of the reaction, specific heat, so boiling point, freezing point, density, dipole moment, so all are intensive property. So इसमें से molar conductance will be the intensive property. So I think क्वेश्चन में जो था उसमें से मोलर कंडक्टेंस होगा इंटेंसिव प्रॉपर्टी, बाकी वॉल्यूम तो एक्सटेंसिव होगा. सो आई थिंक इंटेंसिव प्रॉपर्टीज ही पूछा गया था, जो कुछ दिया गया था कुछ प्रॉपर्टीज, उसमें से इंटेंसिव प्रॉपर्टीज कौन है. सो मोलर जो टर्म होता है, मोलर टर्म, मोलर एंथैल्पी, मोलर एंट्रोपी, मोलर वॉल्यूम, दोस आर इंटेंसिव. नॉर्मल टर्म वॉल्यूम, एनर्जी, एंट्रोपी, एंथैल्पी, these are extensive property means mass dependent. So ये हो गया. नेक्स्ट एक क्वेश्चंस केमिकल काइनेटिक्स के ऊपर था, इजी क्वेश्चंस. जस्ट ये एक रेट, रिएक्शन रेट दिया गया था, नॉट ऐसा दिया गया था, बस पूछा गया था एक रिएक्शन में. सो कुछ पूछा गया था जो रेट रेट फॉर रिएक्शन पूछा गया था, उसमें से रेट with respect to A it's first order and with respect to B it's second order. So ऐसा कुछ पूछा गया था. with respect to A reactant it's first order, with respect to B it's second order. So we can write the rate equation like that, R equal to K A into B square. Since ये पूछा गया था क्वेश्चन में, the rate the reaction is first order with respect to A and second order with respect to B. Now if we change the concentration of A to if we change the concentration of A to double means 2A, and if we change the concentration of B means the concentration of B to half of the original, means if we change the concentration of A is to 2A, and if we change the concentration of B to half B means just we double the concentration of A and we just reduce to half the concentration of B. Now what will be the rate of the reactions? So if you double the concentration of A, then the new reaction rate R2 become K. Since we double this concentration, we can multiply by 2, and since we reduce the concentration of B to half of the original, so this become half of B. Now if we calculate, then it will become half Ka B square. So half means this whole square term become 1 by 4, this 4 and 2, half should be there. So the final rate of the reactions become half of the first reaction rate. So the new reaction rate will be the half of the first reaction rate. So after changing the concentration like this way, double and half, A become double or B become half, the reaction rate become half of the original reaction rate. ऐसे कुछ क्वेश्चन था रिलेशन ऑफ द रिएक्शन रेट. सो फाइनल रिएक्शन रेट क्या होगा, हाफ ऑफ द आर और डबल ऑफ द आर और 1/2 और 1/4 ऐसा कुछ पूछा गया था. सो फाइनल रिएक्शन रेट हाफ होगा ओरिजिनल और प्रीवियस रिएक्शन रेट का. एक नॉर्मल क्वेश्चन पूछा गया था जो लिमिट रिलेटेड क्वेश्चन था, जस्ट एक नॉर्मल क्वेश्चन। सो ये वाला क्वेश्चन में जस्ट एक्स स्क्वायर अगर हम लोग कॉमन लेते हैं इसमें से, तो एक्स बाय एक्स माइनस टू अपॉन एक्स माइनस टू होगा। दिस एक्स माइनस टू बोथ साइड कैंसिल हो जाएगा। नाउ एक्स स्क्वायर टू हाफ था एक्स, इफ वी पुट द वैल्यू ऑफ एक्स देन इट विल बिकम टू। सो ये क्वेश्चन था जो ऑप्शन था 2 0 इन्फिनिटी और कुछ था, इसमें आंसर 2 ही होगा ये वाला क्वेश्चन का। मैथमेटिक्स से और कुछ क्वेश्चन था, उन लोग याद नहीं कर पाया। सो अगर या हम लोग ट्राई करेंगे, या आई विल ट्राई टू मेक अनदर वीडियो बाय कलेक्टिंग सम more questions, and yeah, I think it will take time to collect questions, but yeah, I will make video for another video for this question answer discussions by collecting more questions. So let's see now next questions. So एक ऑप्टिकल डेंसिटी रिलेटेड मींस एब्जॉर्बेंस रिलेटेड एक इजी क्वेश्चन था। सो मोलर एब्जॉर्बिलिटी दिया हुआ था क्वेश्चन में 30,000 मोल इनवर्स सेंटीमीटर इनवर्स, कॉन्सेंट्रेशन था 10 माइक्रोमोलर। सो बहुत लोगों ने इसमें शायद गलती कर दिया, 10 माइक्रोमोलर, वो मैक्सिमम लोगों ने लिखा 10 टू द पावर माइनस 6 मोलर। जस्ट 10 को उन लोगों ने शायद नोटिस नहीं कर पाया। आई थिंक ये गलती इस केस में मतलब हो ही सकता है, ये वाला गलती, ये वाला मिस्टेक हम लोग मतलब मैक्सिमम लोग शायद करेंगे। 10 माइक्रोमोलर जस्ट हम लोग लिखेंगे 10 टू द पावर माइनस 6 मोलर। इसमें जो 10 है 10 इंटू 10 टू द पावर माइनस 6 मीन्स 10 टू द पावर माइनस 5 मोलर। इसमें से आंसर में गलती हो जाएगा। सो लेंथ दिया हुआ सा ट्यूब का 1 सेंटीमीटर एंड लैम्डा 600 नैनोमीटर। सो लैम्डा से कोई फर्क नहीं पड़ता ये वाला क्वेश्चन आंसर करने के लिए। सो ऑप्टिकल डेंसिटी इक्वल टू एब्जॉर्बेंस वी ऑल नो एप्सिलॉन CL, so we'll find the value 0.3. So if we write here 10 to the minus 6 molar, then the answer will become just so 0.03. so ये वाला शायद मैक्सिमम लोगों ने इसमें गलती करा होगा ये वाला। so this is simple questions from so optical एब्जॉर्बेंस और ऑप्टिकल डेंसिटी रिलेटेड क्वेश्चन था कुछ। ट्रांसमिटेंस नॉर्मली क्वेश्चन पूछ लेते हैं गेट में भी, ट्रांसमिटेंस, ऑप्टिकल डेंसिटी, ऑप्टिकल एब्जॉर्बेंस और ए रिलेटेड कुछ क्वेश्चन पूछ लेते हैं। और नेट में भी समटाइम्स नेट में भी एक दो क्वेश्चन आ ही जाता है। सो और एक क्वेश्चन था बॉर्नस्टेन का। सो शायद 4 ऑप्शन दिया हुआ था, 3 ऑप्शन उन लोगों को पता है। 1A is 35 CL, 2A is 35 CL, 1A is 37 CL। सो बॉन्ड स्ट्रेंथ शायद क्वेश्चन पूछा गया था व्हिच हैज द लोएस्ट बॉन्ड स्ट्रेंथ, ऐसा कुछ क्वेश्चन पूछा गया था। सो these are all are HCl bond, HCl bond. So since these are HCl bonds, we have to consider the K, means fourth constant of every bond is similar. We have to assume that K is similar for every bond, means these are HCl bond. Then we can assume assume that only this frequency will inversely proportional to the root over of the reduced mass. We have to assume this K term for equal for every bond. Since it is HCl bond, same bond, we can assume that this K means force constant for every bond will be similar. Now if we assume that K is similar for all case, now nu bar become inversely proportional to the root over of reduced mass. So for reduced mass, if we calculate the reduced mass, for 2A is 35 chlorine, for 2A is 35 chlorine, the reduced mass become more. Since it is become more, the nu bar become lowest for this 2A is 35 CL. So उन लोग बोल रहे थे कि क्वेश्चन में ये पूछा गया था वीक बॉन्ड और या वीक बॉन्ड, इसमें से कौन सा बॉन्ड वीकेस्ट है और बॉन्ड स्ट्रेंथ सबसे लोएस्ट है। सो बॉन्ड स्ट्रेंथ सबसे लोएस्ट होगा 2A is 35 CL, बाकी 1A is 37 CL, 2A is 37 CL, ये दोनों का वैल्यू सेम ही आएगा, म्यू वैल्यू सेम ही आएगा। तो हम लोग नहीं कर पाएंगे, इसमें से कुछ प्रिडिक्ट नहीं कर पाएंगे कौन सा ज्यादा कौन सा कम होगा। अगर क्वेश्चन में लोएस्ट पूछा गया था, सो आंसर 2A 35 CL ही होगा, जिसका म्यू मैक्सिमम है, दैट्स व्हाई इसका न्यू बार और स्ट्रेचिंग बॉन्ड स्ट्रेंथ सबसे लोएस्ट होगा। नाउ मूव टू द नेक्स्ट क्वेश्चन एंड लास्ट क्वेश्चन। सो ये क्वेश्चन अच्छा क्वेश्चन था, सॉलिड स्टेट केमिस्ट्री रिलेटेड क्वेश्चंस। सो पूछा गया था नंबर ऑफ यूनिट सेल प्रेजेंट इन 1 ग्राम ऑफ NaCl। सो दिया हुआ था NaCl FCC लैटिस फॉर्म करता है, ये भी क्वेश्चन में मेंशन किया गया था, NaCl FCC लैटिस फॉर्म करता है। सो नंबर ऑफ यूनिट सेल present in 1 gram of NaCl. Now we know that the crystal density rho equal to Z into M. Z is the so Z is that for FCC that is Z is 4, for BCC it is 2, and for simple it is 1. So now our M is the mass, Na Avogadro number, A is the S length, AQ means volume. So we know the crystal density equal to Z into M by Na into AQ. This is the crystal density of a lattice. So now mass of unit cell M, we can write volume into density. So volume means we can write A cube. A is the S length, A cube become volume. Now density you can write this term Z into M, Na into A cube. So mass of one unit cell now become this A cube cancel out, Z into M by Na. So the mass of the one unit cell become this. So Z for NaCl means for FCC unit cell, FCC lattice become 4, and the mass of NaCl is 58.5. For FCC, Z equal to 4. Now this amount, this is gram. So mass of one unit cell become this amount gram. Now we can write indirectly that this gram mass having unit cell 1. So ये जो वेट है वो है एक यूनिट सेल का वेट, ये जो वेट है कितना सेल का, ये एक यूनिट सेल का। सो 1 ग्राम मास जो होगा उसमें कितना यूनिट सेल रहेगा। So mass of one unit cell, so mass of one unit cell become this gram. So this gram mass having unit cell equal to 1. So ये वैल्यू बहुत मतलब लेस देन 1 मतलब बहुत कम है, 10⁻³ आ जाएगा। सो इतना ग्राम मास जो है एक यूनिट सेल का जो मास है वो मास कंटेन करता है एक यूनिट सेल। सो दिस ग्राम मास हैविंग अ यूनिट सेल we can write equal to 1 because we saw here mass of one unit cell is this. We can write indirectly this gram mass having unit cell equal to 1. So one unit cell having this mass. If we want 1 gram, if we want 1 gram of this kind of cell, what will be the unit cell? So this mass contain 1 unit cell, 1 gram of that solid contain how much unit cell? Now it will just become just 6.023 10⁻23 upon 4 into 58.5. So it's become 2.57 into 10⁻21. So from these calculations we get that 1 gram NaCl contain 2.57 into 10⁻21 unit cell. Simple calculations, density formula we know, mass of unit cell we can know the mass equal to volume into density, volume A cube into density, that formula we will put here. Now this become this gram. So this gram mass for 1 unit cell. So this gram mass for 1 unit cell, 1 gram mass for how much unit cell? It will become 2.57 into 10⁻21 unit cell. So 1 gram of unit cell contain 2.57 10⁻21 unit cell. This is the correct answer. So जस्ट कुछ पॉइंट मेंशन करना है। एक तो ये क्वेश्चन मैंने कर पाया कुछ लोगों से, 20 क्वेश्चंस अभी तक मैंने कर पाया। मैक्सिमम केस में तो ऑप्शन याद नहीं है। सो ये वाला क्वेश्चन में अगर कोई कैलकुलेशंस में मिस्टेक हो सकता है, प्लीज़ आप लोग कमेंट करिएगा। अगर कैलकुलेशन में कुछ मिस्टेक होगा तो कमेंट करिएगा। I will try to check and I will reply so the original calculations and what will be the original answer. एंड अगर ये डिस्कशन में कुछ क्वेश्चन का भी गलत भी आंसर भी हो सकता है, सो आई एम, ये मैं बोल सकता हूँ कि आई एम नॉट 100% परफेक्ट, नॉट 99% परफेक्ट. अगर 100 में 5 और 5-7 क्वेश्चन तो भूल हो ही सकता है आंसर में. सो मैंने बहुत कोशिश किया 90 मोर देन 95% राइट आंसर देने के लिए. अगर क्वेश्चन डिस्कशन में कोई आंसर आप लोगों को लगता है ये आंसर सही नहीं है, इसका मैकेनिज्म सही नहीं है, ये कैलकुलेशन ठीक नहीं है, तो आप लोग प्लीज कमेंट कर सकते हो. कमेंट बॉक्स में कमेंट करिएगा. ये मैं मानता हूँ, आई एडमिट दैट जे अगर मैंने 50 क्वेश्चन डिस्कस कर लिया तो उसमें से तो 3-4 क्वेश्चन भूल मीन्स रॉन्ग आंसर हो ही सकता है. मैंने रॉन्ग मैकेनिज्म भी बोला हुआ हो, मैंने रॉन्ग कुछ कैलकुलेशंस और रॉन्ग कुछ आंसर भी बोल दिया हो. सो ये हो सकता है. आप लोग कमेंट करिएगा कमेंट बॉक्स में. अगर आप लोगों को लगता है कोई आंसर इसका मैंने ठीक नहीं दिया, सो वी विल डिस्कस लेटर. आई विल ट्राई टू करेक्ट माय आंसर एंड आई विल ट्राई टू फाइंड सम रेफरेंस ऑल्सो. अगर किसी आंसर आप लोगों को गलत लगता है प्लीज़ आप लोग कमेंट करिएगा ये आंसर ठीक नहीं लग रहा है, ये आंसर कुछ आंसर अदर आंसर हो सकता है, अदर पॉसिबल आंसर हो सकता है. सो ये एक मेंशन करना था, ये एक पॉइंट. बाकी मैंने जो ये 20 क्वेश्चन डिस्कस कर लिया सेकेंड फेज एग्जाम में, इसमें ऑप्शन तो नहीं था, बाकी जो क्वेश्चन याद था उसको करस्पॉन्डिंग आंसर हम लोगों ने डिस्कस कर लिया. So I think for this video that's all, and I will try to upload another video by collecting some questions, and I think it will take time. So for now that's all. Thank you for watching, and I hope these discussions will help you for upcoming examinations like CSI NET, GATE or BARC also. So आई थिंक ये डिस्कशंस, ये क्वेश्चन डिस्कशन आप लोगों को एटलीस्ट कुछ तो हेल्प मतलब करेगा. सो थैंक यू फॉर वॉचिंग, दैट्स ऑल. स्टे सेफ, स्टे हेल्दी. सो बाय.